In the Consolidated Functions 2 assignment, they asked you to write the equation of something that's a parabola. And I realize that some of you don't remember how to write the equation of a parabola. So I'm going to show you a couple ways to do that. Back in Mod 5, first semester, we learned this equation. G of x equals A times f b x minus h plus k. And we talked about the fact that h was your horizontal shifting, k was your up and down shifting. The only b we used was to make it negative for a horizontal reflection. But in this case, parabolas never have a horizontal reflection. So we're going to leave that part out, which means I can leave out these parentheses and these parentheses and have just a single set of parentheses. And we learned that A was the vertical stretch. I'm going to apply that concept to a parabola because I know that the basic parabola is this, y equals x squared. And my dotted line here is that basic parabola, the parabola you worked with a lot last year. I'm going to be writing an equation for a parabola, and I think I'm going to do the purple one first. So I'll write y equals x minus squared. Notice that it's this function here, except that we took out the f and we put in a 2 exponent because we know the shape we're dealing with is a parabola in this case. And how did I know it was a parabola? Well, it had just one place where it turned. Both of those are that type. And both sides match. It has a vertical line of symmetry down the center. I could say that's my line of symmetry, that you could fold and you could match both sides. So if I'm looking at this purple one, I'm going to say normal parabola starts here at 0, 0, and that's its vertex. This new one has a vertex that is right here. It has shifted sideways 2, that is my h value, and it has shifted down 3, so that's my k value. So when I go to fill this into my equation, I'm going to go x minus 2, remember that, shifting to the right always ends up with a minus, and that's because the formula has a minus in it. And I'm going to get rid of this k and say, in fact, I'm going to even get rid of the minus and say this thing has gone down 3. The only other thing I need to figure out is my a value. And your a value comes from the stretch, the vertical stretch. A normal parabola has a stretch that goes up 1, right 1. It doesn't matter whether you look at it this way or this way. You can think of it as the slope from the vertex to the nearest whole number point. It's not always whole number, depends on the situation, but that's okay. It's normally 1, 1, but in this case, I'm going right 1. And remember how I said we were leaving out the b value? Because the ones we're going to be looking at will always go right 1 and up 3. That's the difference between what we just did with the h and k. H and k was how far did it go from 0, 0 to the new vertex. Now we're talking how far does it go from the vertex to the nearest whole number point we can find. In this case, it's going up 3. That's my a value at 3. And that is my equation of the parabola in vertex form. Let's do that again with the blue one. Y equals ax minus h squared plus k. Y equals x minus squared plus. I'm going to find the hk first, and the hk says, how far did it shift from 0, 0 to get to this point up here? I don't need to draw the lines this time. I can just know that the parabola, look at the parabola's vertex, and that's your h and k. To get from 0, 0 over here, I went left 5, so I have x minus a negative 5, and I went up 9, so plus 9 here. Now, it really makes more sense if I change minus and negative to plus here, because we remember that moving to the left always ends up plus. It's because minus and a negative makes it plus. Then I need to work on how do I find the a value, the stretch. The stretch again, normal stretch is 1, 1. We're doing from the vertex to the nearest point I can find that's whole numbers. Well, I just want to go 1 over. It gets confused if I go other way. So if I go sideways 1, I also have to go 1 this way. So if I'm looking at this, I can see 1, 1. So the a value is 1. But because I'm going down, not up, I have to call this one a negative 1. That's all there is. Might be better if I just wrote it this way. I think that in the comparing functions number 2 assignment, they've given you just plain 1 for that one. But on later ones, you'll have to do more to find the exact a value. Let's write it another way, because they did ask you to write it in 2 forms. This one is intercept form. We did a little of this in, well, last year. I'm sure you did it. But we did a little of this in Mod 5. I'm going to do the purple one first. Y equals x minus x minus. Those P and Q are the X-intercepts. Where does it touch the x-axis? The purple one touches here at 3, so I'm going to put in a 3. It doesn't tell me where the other one is, but I know it's a parabola, and I know they should be balanced on equally on the opposite sides of the line of symmetry. So if that's 1 space right, that's 1 space left. Fortunately, if we look closely at our graph, we can see that that is over 1. So I'm going to say this one's at 1. I'm going to say this is x minus 1. I don't see the x squared in this one, but if I multiplied it out, I could do that. And then I need my a value again. And this is the same one that we did on the other page, but we'll talk about it again. I'm going to go sideways 1 because I don't have a b value to deal with, and I'm going up 3. So my value is a equals 3. If that was hard to tell, you could also try, I'm going to write it and erase it because I don't think it's the best way. X minus 3, x minus 1. Don't know the a value. And I could say, instead of x, I'll take some point I know that's not the vertex. I'll take 3, 0. I'll put in x equals 3, x equals 3, 0. And I could solve that to find out 2. Okay, I said don't use the vertex. Turns out this also doesn't work very well with something that has zeros in it. But if you could find another point exactly, I could do that and just solve to find out the value of A. If you have a graph, it's much easier to do it this way. This is intercept form. Why bother to do a harder way when this is available? Let me do the green one. X minus, X minus. I'm looking for, where does this graph touch the x-axis? It tells me that one is negative 8. So I'm going to do minus a negative 8, which just turns it into plus 8. And this one looks like he's at negative 2. So minus a negative 2 turns that into a plus 2. And then let's check our A value again. Remember, we can think of A value kind of like the slope to the nearest point. So start at the vertex, go sideways 1, and it looks like sideways down, negative 1. I mean down negative 1, negative 1 here. Those are, again, the same A values that I found before. That's probably the easiest way to do intercept form. But I could also do y equals ax squared plus bx plus c, which is standard form. But personally, if somebody asked me for standard form, I would do one of these forms and just FOIL it out to get my answer. Or I would do one of these, but it's more complicated to work this out because I would have to remember to do square that, distribute in the 3, and then subtract the 3 from the end. It's another option, but if they don't say standard form, they just say any form, I would never do that one. Okay, I'm going to make another one that's about, another video that's about finding the equation of the line, but I think most of you, this is all you needed to know because you already knew how to find the equation of the line.